So dear friends and followers, in this today's new video series, we are going to see how you can design this particular Concorde aeroplane in this Autodesk Fusion 360, and I will be walking you through the exact steps and procedures which you need to follow to get this 3D printed. And this particular plane is one of the order which we received for 3D printing it on a scale of 1 is to 400. So let's see. So first let me discuss what are the challenges involved when you are trying to 3D print a particular model like this one. So as you can see, there are a lot of details that are being built into this particular plane, which are a bit difficult for the 3D printer to achieve such a level of accuracy. You can see there are thin walls inside of this large air ducts into which the actual airflow will take place, and these are actually the engines which are used to propel this particular aircraft. We are only building a small toy, but the detailing that the customer wants is of high quality. So what we want to do is we want to reduce the cost and eliminate a few tiny dimensions, and at the same time satisfy the customer needs. So what the customer has given to us is he wants a plane of this particular model in under 1000. So 1000 divided by 75, okay, 13.33. So the customer wants this particular plane to be printed under 15 US dollars. So that's the scale or the cost idea that I have given you roughly. So now there are a few more challenges that are involved. Like if you 3D print this whole plane in a single part, you will have to need various overhangs, because even if you see from horizontal view or if you see it from your top view, in whatever the view you see, there are certain overhangs. So what is an overhang? So let me just quickly make you understand what is an overhang by opening Paint. And this video is going to be lengthy, but I will upload this into various sections so that you can watch in less time. So now what I meant by overhang is you have a certain part like this. And this is your build plate. So let this be your geometry which you want to print. Let me give it a color. So the red color one is the part which you want to print, and let this be your printer bed. So what is meant by overhang? Let's try to understand that. So our Ultimaker Cura will slice this particular model into each individual layers like this, like we have seen in part 3 video. So let me draw it for you so that you will understand it in a better way. So let this be the individual layers of our part. And till here there is no problem in printing. Till this particular portion we don't have any problem, but the problem arises when the printer starts this particular portion. So what is that problem? Let me just quickly show you. So if you carefully observe, when the printer starts this particular layer here, this particular layer, what happens is there is no support and this layer is lying in air. So this particular portion is not having any support, and what happens is this starts sagging down. You know what is sagging, right? I hope you know, because you are mechanical students. If there is any support, this particular material will start sagging down and your part becomes very distortive, and you will not be able to achieve the dimensional accuracy and the requirement that you are intended for printing. So what you need to do? There are two ways for this. One is either you can print supports which will give support for this part from bottom. That is nothing but small pillars kind of structure which Ultimaker Cura automatically develops for us. and this will provide us the support. And what the printer does is, while it is printing these particular two pillars, it also starts printing these two things. So when the printer reaches this particular level, then it starts printing the layer on this particular portion. So now what will happen is, after the part is printed, you can easily remove these two supports and you will get the part that is required of this particular shape. That is one method. Another method is, you can overflip this particular part and print in this particular fashion. If you print in this particular fashion, you have completely eliminated your overhangs and there is no need for supports. That is what is meaning of orientation and optimizing your printing. So in such cases, you can use this. So now what if I tell you, let me open a new file. Let me first save this. And now let me show you what will you do. What will you do if you have a part like this one? If you have a part like this, then no matter whatever the orientation you keep, there will always be some overhangs. So if you put it like this, there is overhang at this particular location and there is overhang at this particular location, which needs supports which you don't want. The problem with supports is it increases your print time and at the same time you will have to post cure it after it is printed, and thirdly the surface finish gets affected. So please keep these 3 points in mind. I will write that down for you here. Problems. Okay, wait. Let me reduce the font size a bit. Okay. So what are the problems with overhangs? With overhangs and supports. First problem is additional supports needed to be printed, which increase printing time. That is point 1. What is point 2? It requires additional post processing to remove supports from the part. And thirdly, it reduces the part surface finish. So these are 3 problems when you have to deal with overhangs and supports. So in most cases you should try out and do some design modifications or do some splitting your model into multiple parts or do some analysis to get the best possible orientation and try to eliminate these 3 things as much as possible. But in such scenarios where it is absolutely not possible to eliminate supports, then there are 2 ways which you can achieve the best possible part quality without having to keep any supports. Now I will discuss them one by one. Let me save this file and create a new one. So now So what are the methods in which you can eliminate supports even if the part geometry is complex? We will take the very good example of this particular plus kind of a symbol. So you can split this geometry into 2 parts. You can create a part like this, and you can also create a part like this. So this is part 1 and this is part 2. So when you join these two parts, then you will get the desired shape. So here there is no overhangs, and here also there are no overhangs. So you have achieved both the objectives of reducing the print time and also achieving the surface quality and also achieving the dimensional accuracy and also achieving to eliminate your supports and not having to create any post processing for your part. So what are, even though you have implemented this particular geometry, there are still certain challenges. What are those challenges? While joining, you will use either glue or you will use snap fits or you will use press fits. So in order to achieve a proper fit, you should be thorough and you should be practical in understanding dimensions, tolerances, limits and fits. We all have studied limits, fits and tolerances in our engineering under the subject known as metrology. So you should understand how you can achieve this. See, if you are 3D printing one particular object and if it goes wrong, you will not be losing much of the money, but you can reprint it with some particular what you can say with the modified settings on your printer with the modified design and reprint your design. But what if you have already given this design for mass production and you have come across this particular loose fit or the parts not being fitted once they have been produced in mass numbers? So those things will also be taken care of. As we go along this course, I will give you an in-depth idea of how you can achieve the assembly quality when you're going for mass production. And I hope I have seen many of your LinkedIn profiles where you have done courses on lean manufacturing, quality manufacturing, and Six Sigma. So we will be dealing with those concepts when we go along this course. So in order to achieve this particular fit, what we'll do is, in order for FDM machines to achieve this particular fit, we will give 0.1 mm of overlap. So what I mean to say is, this is our part and it needs to be assembled here. So this particular gap and this particular thickness should get overlapped. What is meant by overlapping or what is meant by press fitting? So what we do is, let's say this is 2.5 mm. We try to make sure that this will be at least 2.6 mm. This is at design stage. At the design stage itself, we give these particular dimensions and try to fit them by filing the edges and try to fit them by applying some alcohol at these particular surfaces so that it gets fitted properly. So that's how you achieve your fits using 3D printing. So that's what we will try to achieve in this particular plane design as well. So if you can see, this plane has 3 different parts. One is the fuselage or the main body and 2 wings are separate. So if you can see here, there is a particular hole in this particular fuselage and this particular projection on this particular wing goes inside this and gets fitted properly. So this is what we will try to achieve in our 3D printing also. But there are some other problems. Let me discuss those problems with you. One is, if you properly see from the front view, the wings got distorted in this particular manner. So if you have a distortion, then it will create overhangs and it will create layering problems inside your Cura. And once you get this part printed, even though it looks awesome in your Ultimaker Cura, while you are printing this particular part, it gets distorted and it gets stick to the surface, which you cannot remove from the build plate. And even if you try removing your part from the build plate, there are certain problems such as the tips of this particular wing gets broken. So we don't want that to happen. So these are the practical limitations when you are dealing with 3D printing. See, I am not telling you that this particular geometry cannot be printed, but I am telling that there are certain machines which you are dealing and certain processes which you are dealing which are not capable to print this. But if you want an exact model like this one, you should use selective laser sintering, or you should use processes like stereolithography or SLA or SLS. But this particular model cannot be printed using FDM. Then why are we not going for those processes? Because our customer wants this part under 1000 rupees, or in other words under 15 US dollars. Then fused deposition modeling is the only way in which you can produce this part of this size under the cost requirements of the customer. So what he will do? I have discussed this with my customer and he has agreed that he is ready to compromise little bit on the details, but he wants a plane which he can use for displaying at his location. So this is roughly of the size of 24 centimeters and we need to scale this down into 18 centimeters. So that is one thing. And another thing, how you are going to design this. So in order to modify this particular part, it is absolutely very difficult, and I have assigned this particular part to a few of my students and they have come up with various problems and telling me that this particular thing is really challenging to us and please help us. So that's exactly what I will do in this particular video series. And one more challenge is this particular wheel supports. As you can see, this particular wheel has various pistons, cylinders, supporters arrangement. In order to print this in 3D printing, it's very difficult and you need to modify your design a little bit. So we will try to build this particular Concorde plane from the very scratch. So that's the only way in which you can do. So if you want to build this particular scratch from, then you need certain thing that is known as blueprint. What is meant by a blueprint? So if you know the model of the aircraft and if you know the name of the aircraft, you can simply Google search such as Concorde blueprint. This is nothing but your ultimate design image of how the plane looks like and what are its dimensions. We are not worried about exact dimensions, but we will only focus on scaling this down to our requirements. So you should know this particular aircraft dimensions. So if I Google search Concorde length, it is saying me 62 meters. So that's the length of the actual plane. But our customer wants it to be fitted in his palm, to be fitted on his table. So he has requested me for a scaled down ratio of 1 in 400. So let me again calculate that using my calculator. So 62 meters divided by 400 is giving me 0.155, which means roughly 15.5 centimeters. So this should be our length. So we have wrote down our length and let us try to draw a line of that particular length. Let me draw a small sketch on the XY plane and give you an idea of what is 15 centimeters. This particular length of line is having 15 centimeters. But our model which is sent by the customer is more length than this particular line. So what do we need to do? We need to scale that down. But I am not worried about scaling this down on this particular plane, but I want to design a plane which is roughly of these dimensions. I will go to insert and say decal. Okay, I will say canvas. Inside canvas, I will say insert from my computer. And I will choose this particular Concorde blueprint. Display through. And I will click on OK. So now this particular image got imported into my Fusion 360. So now I want to move this. I want to move this exactly near the center. Now my plane is exactly at this particular axis location. And I also need to do one more thing, that is I need to scale this up. And now if I right click on this particular canvases, I will have something known as calibrate. So now I will calibrate this particular model. I will click on roughly on a point which is near my nose, and I will again click on a point which is roughly at the end of my tail, and I will then scale this up to 18 centimeters, for example. 18 centimeters is 180 mm, so I will enter 180. Now automatically my canvas got scaled up, and if I try to draw a sketch, it will show me 180 mm. Now if I try to draw a line starting from the nose and ending in the tail, it is roughly giving me 180 mm. So that's how you will try to develop. So I will delete this sketch and I will try to move this accordingly. I will say edit canvas and try to move this to the center. So now I am happy with this particular sketch. So now I will go ahead and create the sketch. And I want to create these wings for my plane. So how will I do that? So now if you give a very sharp corner at this particular location, it is going to create an error. That's the reason I have given a small projection like this. So now I am happy with my sketch. What I will do is I will give some dimensions. And I have constrained this whole plane into this particular model. Now I will click on finish sketch. And now my wing is ready. and I will press pull and give thickness. And a few students have raised and I have constrained this whole plane into this particular model. Now I will click on finish sketch. And now my wing is ready, and I will press pull and give thickness. And a few students have raised a question that they are not able to enter this 3D domain once they click on exit. So now if you hover your mouse near this cube, there is a small house little icon here. So that's the home button. So if you click on home, you will automatically come from your view into from 2D into 3D. So before coming from 2D to 3D, you need to do two things. First, click on this finish sketch button, and if you are not able to come here into 3D view, just click on this particular home button. And even though if you are not going from 3D to 2D, just go ahead and click on go home. If that also doesn't work, just click on this particular view and you will be able to come to this particular 3D isometric view. And I will give this a small thickness of symmetric 1.5 mm. So 1.5 mm looks very thick. So I will reduce that a little bit. And give it as 1 mm. And this looks good. And I want to give fillets for each and every edge. So now we'll see what is meant by giving fillets. Just click on this particular edge and click and right click it and say press pull. If you click on an edge and say press pull, it is going to add fillet. So now see how smooth the plane is looking like. I will give this 4 mm. And here I will say press pull and say fillet, and I will give 10 mm. Similarly, I will click on this particular edge and give it as 40 mm. And I will select all these edges and give fillet. And I will give a small fillet of 0.5 mm, or I can say 0.6 mm. This 0.6 mm is looking really great. And I will do the same thing on the bottom side also. And now my body is looking great with all these fillets. and let me save this design. Now my design is saved. Now what I'll do, I'll create a mirror for this particular path. How will I do that? I'll go to modify, click on, okay, I will go to create and click on mirror. And inside mirror, you have various options. Under the type, select bodies. And this will be my body or the object. And then come here down and click on mirror plane. It says select. So in order to highlight this one, click on this. And once it is highlighted in blue, go ahead and click on this particular plane. You want to mirror this part across this particular plane so that it creates the other part. And under the operation, click on new body and click on OK. And now my exact symmetric copy of this particular wing also got created. But there is one thing. We have missed out this particular joint which goes in assembling with the fuselage. So for that, we'll do a small feature update. Now what I'll do, go ahead and click on create sketch, and again I will click on this particular face. And inside this face, I will create something known as centered rectangle. I will place the center exactly on the middle plane, somewhere here, and drag a small rectangle like this. And now I will give dimensions. Go to the dimensions, select this particular point, and then select this particular vertical axis to fix this particular location. I will say 30. I will click on this length and say 40. And I will click on the height and say 2. And then I will click on the middle point and I will measure the distance from the horizontal axis, and this should become 0. Okay, this is not working, so delete this. Click on this particular midpoint and then again hold control and then click on this particular horizontal axis and then go here and say coincident. So that is how you will constrain. So now this particular point became coincident with the horizontal line. Now click on finish sketch. And now this particular rectangle got created. And now I will go ahead and click on this particular rectangle and then again right click it and say press pull. And I will pull this one onto this like this. And now under the operation I will say join instead of cut. If I say join instead of cut, automatically this particular projection gets joined up. And I will then click on OK. Now you can see this particular projection got created on this particular wing as we desired. But there is a problem. I will modify this particular sketch and instead of 2 mm, I will give only 1.6 mm. So this is slightly less than this part so that it will not get inserted completely. And now visually you should try to understand whether this particular projection is enough or do you need more projection. Now go to the original assembly and try moving this and check it out. It is very less, but I believe while printing this will be broken. So I am happy with my existing design. And what I'll do is I will again go to create and I will click on extrude, and under the extrude I will select this particular sketch. The current sketch is not getting selected. Click on cancel and draw one more sketch. And what you can do is you can go ahead and pull this particular mirror here. And if you pull the mirror object, what it does is whatever the operations that are done before the timeline will get mirrored up. So that is how simply you can create these bodies. This is body 1, this is body 2. Now let me save and I will record how you can build the fuselage in the next video.